Hey guys, so this week we're starting our energy unit. I wanted to introduce the unit with energy transformations and types of energy. So I'm hoping you've gone through the lesson a little bit so far to see that energy is really hard to define, but basically it's the ability to do something later. And in physics we say it's the ability to do work. So I wanted to introduce this topic with the roller coaster video and then something a little more dear to my heart, and that is the race car track that I have set up in my basement. So here it is. I've got my physics lesson there ready to go, and then my car, my race car, and then the loop-de-loop, of course. So one good way of thinking about energy here is that I've got my little car. That's the wrong one. Okay, so I've got my car on the track, and basically, if I want it to go through the loop-de-loop, what do I have to give it? Well, I have to give it some energy. It has to have enough speed in order to make that loop-de-loop. So if I get it going here, oh, not enough kinetic energy to go around the loop-de-loop. Basically, what you need is enough energy to be transformed into, that gravitational energy, which is at the top of the loop. So I'm going to start from back here and see if I can get it going fast enough to make the loop-de-loop. Nope, that was a fail. Alright, close. If I had hit the turbo, I probably would have made it. So basically the idea here is if you don't have enough energy to do something, then you're not going to be able to accomplish things, right? And we know that from a daily basis. We get up, we have breakfast, and we can get through the day, we can do things. So with transformations, in order to go from one place to another, we have to do work on an object. So the work on the car here was me pushing the turbo, adding energy to the system in order to give it more kinetic energy to do work on the track. So yeah, that was a little intro, and I'm going to bring you through the rest of the lesson now. So if we come back to our lesson here, we've gone through types of energy, okay? So you've categorized the types of energy. There's a bunch of them. Like I said in my lesson notes here, you don't need to memorize these. You just need to know that they exist and that they come in many different forms. Okay, so energy comes in tons of forms. Basically, if it comes from some sort of motion, it's kinetic, and if it has to do with positioning between objects, like for example, if you were to lift a car above the earth, I've basically given it something called potential energy because it has the potential to go into motion, right? And so gravity does work on the car to move it and to apply a force to the ground, okay? So we'll talk about work a little bit later, but I wanted to just go through the first lesson with you. Okay, so for this mini at-home investigation, you need a pullback car. I don't have one of these, and if you don't have one either, that's fine. But if you want to watch that video there, it kind of shows you what a pullback car does. I'm gonna go through this lesson with you using a non-pullback car, but something that sort of goes through the same idea. So basically, a pullback car is you pull it back, and if you were to release it, it would go off on its own, right? So the activity is outlined really well, so that you have 4 different events. You have the hand begins to pull back the car as event 1, so this is here. Event 2, the hand stops pulling back the car. and it releases, and so you release it, the car would zoom off, hit its top speed at event 3, and then it would finally come to a stop because of friction and the loss of energy. Okay, so we're exploring energy transformations in this lesson. Basically, I want you to work through it as if you were, brand new to this topic, which you are, and reference my lesson in case you need to. Okay, I just wanted to sort of briefly go through it with you so that you understand what it's asking you to do. So I'm going to come straight down to here, the energy flow diagrams part. Basically, for an energy flow diagram, you're drawing a circle with whatever your system is defined as, and anything else is the environment. These energy flow diagrams always have the event number, so there's always a moment 1 and a moment 2, or a moment 2, moment 3, depending on what the situation is. Just like when we were doing our kinematics unit, we always have to define 2 moments in time because we're looking at a change in energy between those 2 moments. Okay? So let's see. So you've discovered that energy can transfer or flow from one object to another. So in the pullback car, basically what I'm doing is as I'm pulling it back here, I'm storing energy in that spring. Inside the pullback car is that spring. It's winding, and it's storing potential energy. That potential energy is then going to convert into kinetic energy as the car moves. Well, not off the desk here, but as the car moves, okay? So what I'm doing is I'm applying a force, I'm doing work on the car, and I'm storing energy, and that energy is going to convert into kinetic energy, okay? So what I'm doing is I'm putting energy into the system. The system is my car. I'm putting energy into the system, okay? So energy flows into the system from my hand. Between events 2 and 3, this is when I let go of the car and the car zooms off, right? So all that energy that was stored in the spring is now converted into kinetic energy into the car. So the car gains energy from the spring, since in our energy diagram here, the spring gives energy to the car. Basically, this diagram is showing you how the energy is being transformed or transferred between the 2 objects, okay? So from events 1 to 2, I would have had my hand giving energy to the spring. Events 2 to 3, the spring's giving energy to the car. And then events 3 to 4 is a different scenario, okay? If we were to, say, slow down the car, so now we're looking at events 3 to 4. The car is at its top speed and it comes to a stop, okay? This car is highly frictioned, so it's going to stop pretty fast. So it goes to its top speed and it comes to a stop. So basically what happens in there is that all that kinetic energy is reducing because the car is coming to a stop. And in order to figure out if where that energy went, because energy can't just disappear, we would look inside the car, take the temperature of that spring, because everything inside the car was rubbing, and there was some friction involved. So some of that energy, that kinetic energy, has been transformed into thermal energy. Okay, so the energy is never lost, it's just transformed. On this part of the lesson, it does introduce thermal energy. Okay, so this is the events 1 to 2. So we're looking at how the spring got the energy in the first place. So this is the events 1 to 2. So my hand pulls back the car and stores that energy because it's cranking up the spring, it's winding it up, and it's storing energy in the spring. So the energy flow diagram goes from the hand into the spring. So notice that the arrow points into the circle. The circle is our system, right? So my hand is actually adding energy to the system. When it does that, that's called doing work, okay? And when energy flows into a system, we're doing positive work. And when we're taking energy out of the system, so if we ever had a situation where, the arrow comes out of the circle, that's doing negative work or taking energy flowing out of the system, okay? So this lesson was to sort of introduce the idea that energy can flow between objects, okay? And the direction of the arrow determines the direction of the flow. And then if the energy arrow points into or out of the circle, we see energy flow in or out of the system, meaning we have to do work on the system. Okay, and more work is more covered in our next lesson.